Hi everyone, I'm Pamela Stiles. I'm a lecturer in environmental awareness for the college, Swansea University, and I want to talk about why climate change is about so much more than just the amount of CO2 that we're pumping into the atmosphere. There isn't a nice linear relationship between the amount of CO2 in the atmosphere and the amount of global warming that we're going to experience. The more we increase the level of CO2 in the atmosphere, the more other effects come into play that also exacerbate that warming. And many of these are actually involved in positive feedback loops that could lead to climate change spiraling out of control. A positive feedback loop is simply where you've got phenomenon one causes phenomenon two, and phenomenon two causes more phenomenon one, which causes even more phenomenon two, and so on, which, as you can see, can really easily lead to something like this spiraling out of control. But before we can look at positive feedback loops in climate change, we need to think about what determines how warm our planet is in the first place. And quite simply, it's to do with the radiation that we receive from the sun. So all of our energy comes from the sun. We have this incoming solar radiation, and some of that is absorbed by the Earth, and some of that is just reflected straight back up into space. And when you've got that infrared radiation, that heat being reflected back up into space, it can be intercepted by greenhouse gases in the atmosphere, so things like carbon dioxide. And those molecules are able to absorb that infrared radiation, that heat, and trap it so it's trapped closer to the Earth. So it's like keeping the heat in and keeping the planet warmer. So the more molecules of greenhouse gases like carbon dioxide you have in the atmosphere, the more heat is trapped in and the warmer the planet is going to be. But there's a lot more than that going on. Firstly, not all of the carbon dioxide that we've released into the atmosphere as a result of burning fossil fuels is actually still in the atmosphere. A lot of it has dissolved into the oceans. It's about a quarter of all of the CO2 we've emitted from burning fossil fuels is now dissolved CO2 gas present in the oceans. So that's actually reduced the amount of climate change that we've experienced. The problem is, the warmer it gets, the less good the ocean is at holding on to that CO2. So as it gets warmer, water molecules actually move further apart, and this is causing another effect called thermal expansion. The oceans are actually getting bigger, they're taking up more space because the molecules are further apart, and that's one of the reasons that one of the effects of climate change is sea level rise. But what we're concerned about here is that as those water molecules move further apart, it's less easy for them to keep that CO2 gas that's dissolved trapped in there. And so more of this CO2 gas then bubbles out of the oceans and it goes back into the atmosphere. So the warmer it gets, the more CO2 is released from the oceans, enters the atmosphere and makes it even warmer, which means that even more CO2 is released from the oceans, and so on. So this is one of those positive feedback loops. And that's not the only one that we need to be concerned about. The other effect of warming, which of course we all know, is that the ice is melting, sea ice is melting, and NASA's GRACE satellite suggests that it's actually about 279 gigatons of ice that we're losing every single year. Now remember that we've got this incoming solar radiation, and that some of that is absorbed and some of that is reflected back into space. Well, some surfaces are very good at absorbing heat and others are very good at reflecting it. And ice is actually very good at reflecting solar radiation back up into space. It has a high, what we call albedo, which is just a measure of how reflective something is. So ice has an albedo of somewhere between about 0.5 and 0.7, which means that between about 50 and 70% of all of the solar radiation that hits it just gets reflected straight back into space. But of course, when the ice melts, that reflective surface disappears. It becomes water. Water has a very low albedo. Water is not good at reflecting solar radiation, it's good at absorbing it. And the albedo of water, the oceans, is about 0.06. So only about 6% of the solar radiation that hits the oceans is reflected back into space. The rest of it is absorbed. So the warmer it gets, the more ice melts, the lower the reflectiveness of the Earth's surface, the more heat is absorbed, and the warmer it gets, the more ice melts. It's another one of those positive feedback loops. And carbon dioxide isn't the only greenhouse gas we need to worry about as well. There are many others. One is methane, which we produce quite a lot of through our human activities, things like animal agriculture. So cattle and other ruminant livestock, they produce methane as part of their metabolism. And different greenhouse gases have different potency. So some of them cause a lot more warming per molecule than carbon dioxide does. And that's the case with methane. So if you have one molecule of methane, it's actually responsible for about 25 times as much warming as if you had one molecule of carbon dioxide. And cows and other ruminants aren't the only living things that produce methane. There are some bacteria that do as well. And some of these bacteria have been trapped and sort of locked away in permafrost, where they've been producing methane through their metabolism, and that methane is trapped, locked up in this permafrost as well. But of course, the warmer it gets, the more permafrost melts, and it releases this methane into the atmosphere, which has this very high greenhouse gas effect. It just traps the heat in, makes it even warmer, more permafrost melts, more methane is released. Another positive feedback loop. And that's not the only source of methane we need to be concerned about. There are also deposits of methane hydrate in ocean sediments. They're not stable at higher temperatures, so the warmer it gets, the more of these deposits decompose. And of course, they decompose back into methane, which then bubbles up through the oceans and enters the atmosphere. There are other greenhouse gases we need to be concerned about too. And one that people don't tend to focus on quite so much is water. So water vapor is actually a greenhouse gas as well. It can intercept this infrared radiation and trap heat close to the Earth. And of course, the warmer it gets, the more water evaporates and enters the atmosphere as water vapor. And the more water vapor there is in the atmosphere, the more it acts as a greenhouse gas, trapping the heat in, making it warmer, more evaporation, more warming. Another positive feedback loop. And of course, each of these positive feedback loops aren't just operating in isolation. All of these factors are interacting with each other. And so you can see how it would be possible for this to completely spiral out of control. And it's other human activities that are contributing to the effects of climate change as well, not just the emissions into the atmosphere. Deforestation reduces the amount of vegetation cover on the Earth, so we've got less potential for CO2 to be removed from the atmosphere by photosynthesis. Even something like the decline in the population of the great whales has an impact on this. So whales have a surprising impact on climate change. So they obviously dive down in the ocean, they feed, and they're mammals, they have to come to the surface to breathe. And when they do, and they defecate, they are bringing nutrients up from the bottom of the ocean up to the surface of the ocean, where the phytoplankton live. And phytoplankton are photosynthetic organisms. They can only grow at the surface of the ocean because they need the sunlight for photosynthesis. And so if they haven't got enough nutrients to grow, then their population size can shrink quite dramatically. And without whales to bring those nutrients up from the bottom of the ocean, the phytoplankton population shrink and the amount of photosynthetic uptake of CO2 shrinks again. There's even the fact that we apply artificial nitrogen fertilizers to agricultural land to grow food, and that these artificial fertilizers change the soil chemistry and actually lead to microbes producing more nitrous oxide. Nitrous oxide is also a greenhouse gas, and it's around 300 times more potent than CO2. And this huge problem that we've got with ocean plastic pollution isn't just a direct threat to the marine organisms that encounter it, but as that plastic decomposes and breaks down into microplastics, that also releases CO2 into the atmosphere. So if we don't act quickly and try to address some of these problems, then through these positive feedback loops and these different processes and factors acting together, then climate change could easily spiral out of control. Thank you.